For the given function z equal to tan inverse x by y minus xy, verify whether the statement dou square z by dou x dou y is equal to dou square z by dou y dou x is correct or not. Okay, so here the given function is z equal to tan inverse x by y minus xy. Okay, so to find the statement, I want to differentiate partially with respect to x and y and so on. So first I am going to differentiate partially with respect to y, because first y next x. So differentiating partially with respect to y. So dou z by dou y is equal to differentiation of tan inverse is 1 by 1 plus x square, and the differential of inner term with respect to y, but the differential variable y is only in the denominator, so we can apply 1 by x formula. 1 by y differential is minus 1 by y square. So differential part with respect to y over, minus here with respect to y is 1 into x, x. So now I am going to simplify. The simplification is, this is minus x by cross multiply y square plus x square by y square into, I took minus x here, so 1 by y square minus x. Y square cancel. So this is dou z by dou y. It is minus x by x square plus y square minus x. Okay, so next I want to differentiate with respect to x. Differentiating partially with respect to x. So this is dou by dou x of dou z by dou y. Okay, so with respect to x means the x is numerator and denominator. So apply u by v formula. So take minus outside, apply u by v formula. So v into differential of u, x differential is 1, minus u into differential of v, denominator differential with respect to x is 2x, by denominator v square. So u by v formula over, minus x differential is 1. So the differential part over. So now this is dou into dou square z by dou x dou y is equal to, so now I am going to simplify. Take minus inside, minus x square minus y square minus minus plus 2x square by x square plus y square the whole square minus 1. So what is the simplification? 2x square minus x square is x square minus y square by x square plus y square the whole square minus 1. So this is the dou square z by dou x dou y. This is the value. So next I want to find out RHS value dou square z by dou y dou x. Okay, to find RHS, so once again I'm going to take z value. So z equal to tan inverse of x by y minus xy. To find dou square z by dou y dou x, first I am going to differentiate partially with respect to x. So differentiating partially with respect to x, dou z by dou x. So tan inverse x is 1 by 1 plus x square into differential of inner term with respect to x. The x is only in the numerator. So x differential is 1, so 1 by y minus x differential 1 into y, y. So the further simplification, so this is, take y square here, y square plus x square divided by y square, take into numerator, into 1 by y minus y. 1 y will be cancelled. So dou z by dou x is equal to y by x square plus y square minus y. So one time differential with respect to x over. So now here I am going to differentiate partially with respect to y. So dou by dou y of dou z by dou x is equal to, so with respect to y, but y is both numerator and denominator, so I am going to apply u by v formula. So what is u by v formula? V into differential of u, y differential is 1, minus u into differential of v. Differential of v with respect to y is 2y by v square. X square plus y square the whole square, minus y differential is 1. So now I am going to simplify. So this is dou into dou square z by dou y dou x is equal to, so this is x square plus y square minus 2y square by x square plus y square the whole square minus 1. So what is the simplification? So this is x square minus y square by x square plus y square the whole square minus 1. So this is dou square z by dou y dou x value. And already we found dou square z by dou x dou y. Both are same. Therefore dou square z by dou x dou y is equal to dou square z by dou y dou x is correct. Hence verified.